Hello, in this video we will talk about problem D. So in this particular problem you have given an integer k, and for that particular integer you have to find out minimum n such that n factorial modulo k is equal to 0. In other words, n factorial should be a multiple of k. So we can write n factorial should be a multiple of k, right? Let's take an example. In this particular example, you are given k as 30. For that particular example, minimum n will be 5 because 5 factorial is 120 and 120 modulo 30 is equal to 0. You can check other numbers less than 5 and you will find that those numbers will not be eligible because factorial of those numbers will not be a multiple of 30. So for that particular case, answer is equal to 5. Let's dive into the solution part. If we make the prime factorization of k, we will find something like this: p1 to the power alpha 1 multiplied by p2 to the power alpha 2 multiplied by p3 to the power alpha 3, and so on, right? This p1, p2, p3 represents the prime numbers, and alpha 1, alpha 2, alpha 3 represents their power. One thing to understand here is that if n factorial wants to be a multiple of k, n factorial must contain these terms, right? Otherwise, n factorial won't be a multiple of k. So this is our first example, first observation. The second observation is, from the first observation we have seen that n factorial must contain p1 to the power alpha 1, p2 to the power alpha 2, and so on. If we break this line, we can say that n factorial must contain alpha 1 number of p1, n factorial must contain alpha 2 number of p2, and so on. Suppose for a particular k, after a prime factorization, we have got 2 to the power 3 multiplied by 3 to the power 4 multiplied by 5. So n factorial must contain 2 to the power 3, 3 to the power 4, and 5, so that n factorial becomes a multiple of k. Now let's go to the third observation. For a particular p to the power alpha, we need to find out the minimum number up to which alpha number of p is found. Suppose our p to the power alpha is 2 to the power 3. That means we need to find out the minimum number up to which we can find 3 twos, right? So we can see that 1 give us 0 2, 2 give us 1 2, 3 give us 0 2, and 4 gives us 2 twos, right? Because 4 is 2 square, so we will get 2 twos from 4. So the minimum number up to which 2 twos can be found is 4, right? So try to understand this. If n factorial wants to contain 2 to the power 3, it must contain 2 and 4, right? It must contain 2 and 4. But we can say that it must contain 4 only, because if it contains 4, all the number less than 4 will also be present because it is in factorial form. So 2 will also be present on that n factorial. So we can say that n factorial must contain 4, so that 2 to the power 3 is present in the n factorial, right? That's why I have written here that what is the minimum number up to which alpha number of p is found, right? That minimum number is 4. You can further go on 6 8, but those will only increase the number of twos, but we don't need more twos. We need only 3 twos, right? So 4 is sufficient. So for 2 to the power 3, we can see that we need 4. For 3 to the power 4, we can see that here again that for 3 to the power 4 we will actually need 9, because 3 will give us 1 3, 6 will give us 1 3, 9 will give us 2 3, because 9 is 3 square, right? So in so if n factorial wants to contain 3 to the power 4, it must contain 3, 6 and 9, right? But we can say that only containing 9 9 is enough, because if it contains nines, then rest of the numbers in will be automatically inside that n factorial, because if it contains 9, 1 to 9 will be automatically inside that n factorial. So we can say that n factorial, the minimum number which is required so that four threes can be found, is 9. So we can see that 9. For 5 we will find out that that will be 5, right? So we can say that if n factorial wants to contain 2 to the power 3, it should contain 2 and 4. But if we can say that it contains 4, that is enough, because containing 4 will automatically include 3, right? So same goes for 3 to the power 4 and 5. So it boils down to this: if n factorial wants to contain 2 to the power 3, it must contain 4. If it wants to contain 3 to the power 4, it must contain 9. If it contains want to contain 5, then it must contain 5. But we can say that containing 9 is enough, because containing 9 means 4 and 5 will automatically get included, right? So we can write that containing 9 is enough, because 4 and 5 will be automatically included. Because containing in factorial containing 9 means all the numbers from 1 to 9 are already present in the n factorial, right? So 4 and 5 will be automatically included. So the answer here is 9. So the solution boils down to this: first we need to find out the prime factorization of k, and you can do this in square root of k times. Then the prime factorization will look like this, and for each and individual term we need to find out the minimum number up to which alpha number of p can be found, and the maximum of those minimum numbers will be our answer. So the first part is very common, and you can find this algorithm in the internet or in the YouTube also. I will show you the second part, where you can find the minimum number up to which alpha number of p can be found. So suppose I'm coding it in Python. Suppose you are forming a dictionary, and that dictionary you are uh, uh, you are recording you are recording the p and alpha values. So in that example we have seen that for 2 the power is 3, for 3 the power was 4, and for 5 the power was 1, right? So you can write, so what you will do, so for the first information, you need to find out the minimum number up to which three twos can be found, right? So what we will do, you will traverse each multiple of 2 and cumulatively add the number of twos seen. If that cumulative sum becomes equal to number of tools required, you will say that that particular you will say that that particular multiple is the minimum number required. So what you can do here is, for I in dec, so that is our cumulative sum is equal to 0, and let's assign the value of I, uh, uh, let's assign the I in a value. Okay? Then let's run a while loop. Let's take function, and in this function we will input value and I, right? So this function will return me the cumulative sum, right? And in this function the input argument are the cumulative sum, uh, the value and I, right? So if our C sum is equal to dec of I, let's declare a variable here, answer is equal to 0. If our cumulative sum equals to dec of I, then our answer is equal to max of answer, comma, that particular value, right? Let's call this multiple. And if it's not, then our multiple will get increased by I, right? So here what we are doing, we are jumping to the next multiple, right? So if our cumulative sum becomes equals to 3 in that case, then we are calculating the answer, and if it does not, then our whatever our initial multiple was will get increased by I, right? And now let's declare that function. This will take our C sum multiple and I, right? So if let's take another while loop. So if we say if multiple mod I is equal to 0, our C sum will get increased, and our multiple will be multiple divided by I, else it will break, and with it will return the C sum value. So that is the code, how you can find out the minimum number such that alpha number of p can be found. So that's all for now. If you have any questions, please do the comment. And making videos is a lot is tough, I guess, and a like and a subscribe would be really appreciable. Thank you.